All right, so we're going to keep talking about triangles, and we're going to learn two new words today. The first one is medians, and the second one is mid-segments. So these are both different kinds of line segments that we're going to see in triangles, and each one has specific things about them we need to know. So the first thing we'll talk about is a median. So a median of a triangle is a segment with endpoints being a vertex of the triangle, so right here, and the midpoint of the opposite side. So this is the midpoint. The way we can tell it's the midpoint is because these tick marks indicate to us that these two segments are congruent, so that tells us that D is the midpoint of AB. Again, the median goes from the midpoint of one side to the angle across from it. So every triangle has three medians, and if you look up at our picture again and you think about this midpoint connecting to this side, and you think about this midpoint connecting to this angle, then you kind of get the idea. All three medians intersect in one point. Now my picture is not very good, but if we look down at the one a little bit lower, we see a lot better picture of it. That point where all three medians intersect is called a centroid. Okay, that's the point where all three medians intersect. And there's something particular about where it's always located. The centroid of a triangle is always located 2/3 of the distance from each vertex to the midpoint of the opposite side. So that may sound confusing, but all it means is if you look at this mid segment right here, I'm sorry, if you look at this median right here, this distance that I just highlighted in green is 2/3 of this distance that I highlighted in yellow. So just remember the centroid is 2/3 the distance to the vertex as it is the distance from the vertex all the way to the opposite side. So we'll do some quick examples and it'll make a lot more sense. But as far as our picture goes here, AP, so the distance from A to P, is 2/3 the distance from A to Y. The distance from B to P, so BP, is 2/3 the distance from B to Z. And lastly, CP is 2/3 the distance from C to X. We'll take a look at what that looks like in a problem or in an application. So we have triangle LMN, that's this triangle over here, and it tells us that RL, so from R to L, is 21. And it asks us to find LS. Well, LS is right here. So it's from here to here. So you can see it's not the whole distance, but we know from our theorem that it's 2/3 the distance. So if RL is 21, then we can say that LS equals 2/3 of RL, which is 21. And you can put that in your calculator, or you can realize that 21 is 7 times 7 times 7. So 2/3 of that is 14. So however that works for you, but you need to be able to figure out what 2/3 of 21 is. So LS, the distance from here to here, is 14. And hopefully that makes sense to you that this last distance would be 7 because 21 is 7, 7, and 7. So that's why this distance is 14 because it's 2/3 of the whole thing. Now let's look over at NQ. So from N to Q is this entire distance from N to Q. And it tells us that SQ, so we'll do SQ in purple, is right here. It tells us that is 4. Well, if we kind of go with our same pattern that we had here, that this little piece is 1/3 and the big piece is 2/3, then that should make sense that this is 4 and this is 4. So NQ equals 12 because the distance from our centroid to our angle over here is 8 and this is already 4, so 8 plus 4 is 12. All right, so you give this one a try and We'll check this one in class and see how you did with it. We're going to move on though. All right, the next thing we're going to talk about is a midsegment. Now, a midsegment is just what it sounds like. It's a segment that connects the two midpoints on a triangle. So if you look at this triangle, we have a midpoint here, and a midpoint here. So this segment that goes from X to Y is a midsegment. Okay, and what's interesting is that these three midsegments all connect, and they make this little triangle here, and that's called a midsegment triangle. So it's a triangle that's made up of the midsegments of a bigger triangle. And what you'll learn is kind of interesting is this triangle, this triangle, this triangle, and my midsegment triangle are all congruent triangles. They all have the same area, they all have the same perimeter, they all have the same side lengths measurement, so it's kind of a cool thing. And the triangle midsegment theorem tells us that a midsegment of a triangle, so that's this blue line right here, DE, is parallel to the side of a triangle. So this blue line is parallel to this red line, so that's kind of convenient. And its length is half of that side. So the segment DE is 1/2 of segment AC. So that comes in real handy and makes these problems really easy. So let's go ahead and look at a couple of examples. It says find BD. Well, BD is right here. Now, we just said that our midsegment is half of the side that's parallel to. Well, that's this side right here. So BD just equals 1/2 of 17. And you can type that in your calculator, and that is going to be 8.5. All right, so now we look for angle CBD. So we're going to switch to a different color, angle CBD. Well, that is this angle right here. And remember that I told you about all these triangles is they're all congruent, they're all the same. So we have this triangle here that is made up of this midsegment, this side, and this side. So where these tick marks are, where this has 2 marks, this also would have those 2 marks. And where this has 3 marks, this would also have those 3 marks. And the hypotenuse, or maybe not the hypotenuse, but the side here between them is the same. So these are congruent triangles. So the angle between the 3 marks and the hypotenuse should be the same in both of them. And so that's this angle between the 3 marks and the hypotenuse. So that's this 26-degree angle. So those 2 angles are the same, which works out kind of convenient because they asked us for angle CBD. Well, the measure of angle CBD is 26 degrees. Okay, so here's another example. One thing that we learned is that the midsegment is exactly half of the segment it's parallel to. So we know that n plus 14 equals 1/2 3n plus 12. Now there's lots of ways to solve this, but we're just going to do it the fancy old-fashioned way and distribute. So we're going to have n plus 14 equals 3 over 2n plus 6. Half of 12 is 6. Right, then we are going to subtract 6 from both sides. So we're going to get n plus 8 equals 3 over 2n. We're going to subtract n and get 8 equals, now 3 halves minus 1 is like 3 halves minus 2 halves. So that's 1/2 n. Hopefully you remember to get rid of a fraction like a 1/2, we multiply both sides by whatever's on the bottom of it. So we get 16 equals n. So the value of n equals 16. So go ahead and give this a try on your assignment, and we will go over it tomorrow, but everybody should be working on this today.